So if you're anything like me, you started your backend development journey in TypeScript. You were writing express backends, doing all this stuff, but there's a better way. There's a way to make your backends faster, more scalable, easier to write, and far, far more performant. Let's talk about how. But first, before we get into that, make sure if you guys are not already subscribed that you go ahead and do that. Tons more GoLang content coming out over the next month or two. Going to be uploading something every single day until February 28th. So make sure that you are here for that. Really helps me out, helps grow this as fast as humanly possible, and helps make things better as fast as humanly possible. So with that out of the way, let's break down how we're going to make a better backend. So jumping straight into this right now, I have the Better Backend Git repo, which is totally free, open source, and down below. This is not fully complete, and I want to add way more to this. I want to eventually turn this into a thing where you could just go into your CLI and be like, create Go app or something along those lines. Not sure what I want to name this stack and package or whatever, but effectively have it so that you can go in, create a brand new Go app from a template, and it'll template out. You can pick your database, you can pick your what packages you want to include, what features you want to include, all this stuff. It'll get it scaffolded, structured, and printed out for you with no effort whatsoever. And the reason I want to do this is because GoLang is a phenomenal language, but a big issue it has is it is hard to figure out how to structure these projects. It's hard to figure out a good way to put all this together. And I think what I've got right here is pretty good. It's a great start, and I want to iterate on this a ton, but for today, I want to show you how I make better backends. So let's jump into the code. So the first thing you're going to notice is that I have made a ton of different directories here. I have app, config, database, docs, handlers, models, router, and then my main.go, and a ton of stuff out here. So what I want to do is I want to go through each directory, explain what it is, why it's there, what you put inside, and why. Then I'm going to go through and kind of explain the process of building this. Then I want to show you how to actually run this in dev and do all that stuff. We have some really great scripts built here to make it super easy. This is all really nicely contained, and I've implemented a bunch of the stuff that we've talked about and some of you guys have mentioned and brought up, like errors in here and a bunch of really cool stuff like that. So without further ado, let's start at the root of our project with main.go and go from there. So within our main.go, you're going to notice this, all these comments up here. We're going to talk about that later on, but that's for our documentation solution. But the key here is all main is really going to do is just handle our root errors. So I have this app.setup and run app, and this will take an error out. And then if I get an error, I'm going to panic. If you want to add some custom error handling in here, you can. Maybe later on, I'm going to update this to have some better error handling. But for now, all it's going to do is just panic this error and crash if we get something thrown out of setup and run app. So main is really nothing special. All it is just an entry point to our app, so that if we do go run main.go, we do go build, it'll just build this and run from here. So let's get into the actual packages. The first package we're going to have is our app directory, and this app directory is sort of meant to be the place that handles all the configuration of your app. Now this isn't necessarily going to contain all of your roots and all of your handlers, although you could organize it that way, but I've chosen to break these out so it's easier to see in a root. And what this app directory is this is sort of like, this is where your configuration and setup for your actual application is going to happen. So what do I mean by that? Well, in here I have this setup and run app function, and what I'm going to do in here is I'm going to do a bunch of different things. First, I'm going to load our environment variables. Within this config directory, I have some basic stuff that we can do to set up our app. One of these things is going to be to load environment variables. This is a very common thing you're going to need. I have this little custom load env script, and basically what it does is it's going to load this environment variable of go environment. If it gets something like production, then it's going to assume that we're in a prod environment. We don't want to be loading a .env file, so it'll just skip all of this. But if we don't have that, or we have it set to development, we're going to go ahead and load our .env, throw back our error. Very basic. Going back to our setup, we then have our database. For this example, I'm using MongoDB. In the future, when I turn this into a real template type thing, I want to have this support both relational databases and SQL databases, and you can pick which one you want right out of the box. So I started with MongoDB because that's what I typically use with Go. Just the way my projects end up, I typically end up with SQL and more of my TypeScript stuff, and I've been using MongoDB and Go together a lot. I think the two go together really well. So wanted to start here with MongoDB. The way I have this structured is if within our database directory, if we go in here, I just have this mongo.go. Eventually we'd have like a sql.go. And then what you do in here is I have my Mongo client, which is just going to store a reference to whatever MongoDB connection I have open. Then I have my database name, which is going to be loaded out of an environment variable, because I don't every time I want to go into a collection have a sort of random string that I have to put in. One of the big things that I wanted to focus on here is single point of control. And I'll talk about that later when I get into the sort of theory behind all of this. But I effectively want there to be one place where you decide what your database name is. Then every single time we reference it, it's going to read out of this variable. So we have this get collection function, which is how we're going to actually get references to a collection within our methods. But then the main one is going to be this start MongoDB. We're going to load our URI. If it's not there, throw an error. Load our database, which is, like I said up here, it's going to be the name of our database. Again, you have to set that environment variable. Then finally, we're going to go ahead and just initialize our client. If there's an error, we will panic this because we have to just crash right here, because if we fail our database setup, it's just not going to work. And then finally, we go ahead and return nil. Then we also have this function of close MongoDB, so that if we want to have a graceful shutdown, we can go ahead and just close our MongoDB instance here. These two panics, looking back at this, these should probably be returning to throw up to the central thing. I will change that later in a future iteration, but for now, it doesn't really matter. Going back to our setup, we can start our database, then we defer closing our database. That just means that whenever this function terminates, we will terminate our database connection. This will basically never terminate unless we throw an error. So then after this, we need to actually create our app. So that first part was the setup. Now we're going to set up our app itself. So we create a new app, which is just fiber.new. Then we need to set some stuff up. So we're going to want to do app.useRecover.new. And then we're going to want to use a logger so that we can log all of our, all the events that come in. This is also where you could do cores or whatever you want to do. This is where I put all my middlewares. Then I go ahead and set up the routes. And this is where we get into our routes and handlers directory, which are the sort of meat of the app. So let's start with routes. So we go into router.setup_routes. So within our router, I have this main.go. And in this right here, I have my function to set up all of our routes. And we can make up multiple functions in here. Right now for this, it's pretty basic. I just have setup routes. And what this is going to do is I will pass in a pointer to our Fiber app instance, and I can bind into it whatever routes I want. So if I want to bind in health, I can bind that here. I want to bind in the to-dos group, and then all of these different things. And then I'm putting in their handlers. And these handlers are the actual things that are going to run whenever we run these routes, and these are going to come out of our handlers directory. So I have two different files in here. First one is health. This is really basic. All it's going to do is just return c.string OK. So it's going to send out an OK if the server is running. This is a description of how it actually works. This is for our auto documentation feature, which I'll talk about later. But we have this in here, and then within our to-dos right here, we just have a basic CRUD app in here. The point of this is not to go over a CRUD app, it's to go over how I structure a project, so I'm not going to go into detail on this, but effectively what I'm doing is I just have two GET requests, a post, a put, and a delete, so that we can read and write to a to-dos table. Nothing too crazy, but it's good to just sort of show this working. I have all of that in here, and then the key right here is going to be these documentation features. Again, I'll talk about that in a moment. We've got all this stuff, makes it really nice and easy, and gives you a good example of how you can do this. You can structure these files and stuff however you want within these directories. It's not super prescriptive on, oh, they have to be here or there. This is just a nice way I found to organize this stuff to make it not just have 15 different Go files in the root directory, but sort of put these in a nice place and have a really easy organized way to look at everything. So that if I go back into this router right here, I can see, okay, if I go into my handlers directory, I can grab my handle all to-dos, all these. So I can make as many files in here as I want, but they'll all be part of the handlers package. And then I can set them up within the router package, and then those are all going to go back to the app package, which will then be run through the main package. So it seems a little complicated, but it actually just nicely cuts everything up, and it makes the app much more modular. That's the key here, is these are very, very modular. So that's the router. Then the handlers directory, nothing too crazy. Then finally, let's talk about the models directory. This is just where I would put all of my database models. I like to, even in MongoDB where you don't need a schema, I still like to have these. So what this is my to-do entry is going to be modeled like this. I have a name, title, completed, description, and date, all of that in here. Then whenever I need to reference this somewhere within my handlers, usually I can just use models.whatever. So right here, whenever I'm pulling a to-do out of the database, it's going to be var to-do models.to-do. So I'm pulling this struct out of my models package, and that's a single point of control for what our database entries need to look like. I'm not putting these DTOs in there because these are unique to each root. Every single time we have a different root, we're probably gonna have a different DTO. But if you're not familiar with a DTO, that's just a data transmission object. So this data transmission object is unique to each root, so I make these custom every time, but these models aren't going to change. These are the underlying way that our data is being stored, so I like keeping them in a central place. Then that is basically every directory except for one, and that's going to be the docs. And this, you don't ever want to edit what is in here, but what this is going to do is this is just where the data is stored for our auto API documentation. So if I go ahead and I run make docs, and I'll talk about make in a second, it's going to say docs is up to date, and that's because I already have my documentation generated. So if I go ahead and I do go run main.go, If I open this up, it'll take a moment to build, and I go to localhost 8080, nothing's going to be here. But if I go to here /swagger, what I'll get here is I'll get auto documentation. So all of those comments I made on each of those handlers, those will go ahead and actually create documentation for each route. So if you remember on my health check back here, I have a summary, a description, a tag, what it's going to accept, what it like, the type of the procedure, the success cases, and all this stuff. So if we look back at this right here, I can see all of this information here. So show the status of the server, that's coming from here. Get the status of the server showing here. The tag is going to be health, so on and so forth. And I have that for all of the to-do. So this is a super easy way for you to go in and see what's actually happening within this API. And if you need to consume this somewhere, you can just give people access to this, and then now they can see how your API works, and then they can actually use it. So it's just auto documentation with some basic comments, which will make your life 100 times easier. So I wanted to make sure to include this within. It'll also show you the models that we're using here. So most of these are just handlers dot whatever. Then I have my models dot to do, all that basic stuff in there. And that is all being run through the Swagger package, which is then being stored in these docs. And to do that, I just have to run make docs, and that is going to actually build my documentation. So we have to rebuild the documentation every time we want to refresh it. But that's not a big deal to do because I just made a little script for that. Now, getting outside of these sort of, getting outside of the app itself, if we look at the sort of stuff that's surrounding it, if you're familiar with like the Node ecosystem and stuff like that, it has npm, package.json, all that stuff. So you have these npm scripts that you can set and run. Well, Go doesn't have that. It doesn't have a package.go or whatever. So all we have is we have, well, right here I have .env.example, nothing too crazy. This, I can show this because it's not important. All you need to set for this example is a MongoDB URI, a port, and a database, nothing too crazy. Then the git ignore is just basic, but what we have down here is we have this go.mod, which is effectively what will dictate is within our actual app. So this is basically our list of packages, and this is maintained automatically by Go. If you're using like the VS Code extension for this, you don't ever have to actually worry about maintaining this, but this just has listed in it all the packages we're using and all of their respective versions. Go.sum is just a bunch of metadata stuff. I don't really know what happens in here, and don't ever edit either of these, but just know that they exist. Then the license is just MIT, you're free to use this, have fun, I don't care. Main.go, this is, like I said earlier, the entry point. Now this up here, all of this comment, this is actually like the root stuff for the Swagger root. So if you look up here and it says the better backend template, that's coming from here. So all of this basic information comes from here. Then the key here is going to be our make file, and this is a super basic one, but right now all I have in here is I have docs and I have dev. So if I go ahead and I do make dev, that's going to run the air command. So you can basically set up commands that you can run in here. If I do make dev, this is actually going to enable hot reloading on our app. So if I go into our main.go, and if I go ahead and add something here, and let's just do fnt.println hello. If I just add something in here, it'll say main.go has changed, it'll build it, and then it'll run it, and it'll show me my hello up here. So this allows us to sort of get that nice experience you would get with like NodeMon or something like that, where every time we update a file, we get a hot reload. It's not a hot module replacement type thing like it is in Node or TypeScript or whatever. Those are going to be way faster to reload. This is a little slower because it's actually going to be building the executable every time and then running it, but it's still way better than having to Control-C, go run main.go every single time. So this is just a nice DX sort of thing. Then I have my make docs, and the point of that is to just initialize our Swagger stuff. It'll get the docs root built. This TMP directory is just for the air package, air.toml is configuration for air, which is how we keep continuously building this. And then we have our readme.md in here. So that's all good. I have that set up. I'll make sure to update this before this goes live. There are a couple things that you need to make sure you have installed, chiefly of which is going to be the, you need to make sure that you have air installed, and you need to make sure that you have air installed, and you need to make sure that you have Swagger installed to get the full functionality out of this. And those need to be installed via go install. So you need to do go install whatever. I will add that to the README in the future before this goes live. I'll put those down here. But you need to make sure that you can actually install them and run them and all that. Your path is correctly configured. I made a very short video about that this morning. I think it's like up here. Make sure that if you get issues with that, watch that first, see if you can find anything there. It's super important to be able to install these packages globally because we're just actually running the air command. We're not just doing like go run air or something. We're just doing air. So this is now on my path and I can execute this anywhere. So you need to make sure that you're able to execute it anywhere as well. With all of that out of the way, let me just demo what the app actually does. I'll talk about some of the theory behind it and then some of the future plans. So what I'm going to do here is if I just do go run main.go, we can go ahead and actually test this out. So right up here, if I do a get request to this, I'm going to have nothing in here. If I do a post request, I will be able to create, so it'll insert with an ID of whatever. I can grab this ID, and then if we get this again, this will get all of them. So it'll get all of the different to-dos we have in here. I can paste that ID in, hit send, it'll just get the one. I can put here to update this, so I'll remove the updated from it, hit send, updates one, get it again to get the information. Yep, there we go. It's been updated, and then finally we can delete this, deleted it, and we can go back and get, and it works. So well, here it's going to say 404 actually, because I still have this ID in here because this doesn't exist anymore. But if I delete this, now it'll be an empty array. So the point here is it's a very basic CRUD app. It gives you a good example of some basic functionality with MongoDB, how I like structuring all this stuff. If you want to get deep into the root, like I said, the code, you can go take a look at it. Should give you an idea of how all this works. But sort of this kind of guiding philosophy behind this was I wanted to come up with a modular way to structure a Go app that makes it really easy to add and subtract packages, roots, and stuff like that, because a lot of the ways I see them structured is they are all just kind of throwing them randomly into a ton of different files. And that can work, but it gets really hard to maintain, and it's really hard to pass that off to other people. And that's one of the things that Go sort of lacks in, is it's not super opinionated. So I wanted to add some of my own opinions to there and how I like to structure this. If you have a different way of structuring it, that's great, but this is how I like to do it. And really the key behind that was making it so that my app, anytime I want to edit my app and set up stuff there, I can do it in this app directory. And then anytime I want to update my router, I do it within this router directory. And then anytime I want to add a handler, I can do it in this handlers directory. So I know what I'm looking for. If I need to go ahead and update my, say one of my routes is broken in production, I know where to go. I know, okay, I need to go to my router. I need to find that route. I need to grab its model and then go in there and do some fix on it. It makes it super easy to deal with. And then I tried to also set this up to have as strong of single point of control as humanly possible. And what's that mean? It basically just means I want it to be like there's one place where everything gets, where anytime you need to deal with something, you only have to deal with it in one place. And the best example of that is going to be with the database. So in the database right here, this database name, normally you would have to put this string in a bunch of different places. I've been guilty of this myself, where we just have database name and you have to constantly put that in. I wanted to just make it so that this will only ever come in once. So I'm requiring database as an environment variable. So you have to provide a database, and then that'll get passed in as the actual database here. Then we pass in the collection itself. You can pass that in dynamically because we can't keep that static, but I only want to ever have one database name. And same thing with error handling. I want to do all of my main root error handling at main. So if I want to change this to, instead of panicking, I want to change like the formatted or something like that, whatever you want to do, that's super easy to do. You can do that all here. Or if I want to update something about my app, I can do all of it right in here. So I have one place to do everything. It just makes sense. So that's kind of how I like to structure this stuff. Like I said, I want to turn this into a more serious package in the future. Eventually get it to the point where you can do go install whatever I end up naming the package in stack or whatever. The better backend is just a cheeky thing I did for like the title or whatever. That's not going to be the final name. That's dumb. So I'm going to find some sort of name. If you have any names for it, let me know. I'd love to get opinions on that because I'm terrible at naming things. So want to figure out a good name for this, and I want to turn this into like a package where you could do go install whatever it's called, and then you can just do like create Go app or something, and then it'll go through and it'll give you a nice little like step-by-step CLI walkthrough of, you can pick, okay, what database do you want to use? Do you want to use MongoDB or do you want to use SQL? Then you pick which one you want, and then you click on that, and then it'll take you through the next step. And it's like, okay, what middlewares do you want? What extra features do you want? Do you want logging? Do you want this? Do you want that? All this stuff. Make a really nice backend creation experience so that you can scaffold a Go backend in 5 minutes and then just get actually writing what actually matters, which is the code. This will make it super easy to create highly performant backends, and that's the key. I want to make it easy to make good backends, where right now it's the easiest way to do it is to use TypeScript and stuff, which is worse on an objective level when put next to Go, but it's a lot easier and more developer friendly to do. So I want to make Go that developer friendly. So that's something we're going to be working on 100%. Got big plans for that. Very excited. But for now, let me know what you think of this. If you have any questions about it, or if there's anything you'd like to change, please let me know. Like I said, all of this is available. I have a link down there. Take a look at it, go through it, try it out on your own computer. I'll try and make sure that the README is as detailed as humanly possible. Again, any issues, let me know. And yeah, I think that's it. If you made it this far, thank you, and I will see you later.